this video, you will learn how the Apache Spot project accelerates cyber threat detection and response by allowing analysts to quickly explore massive amounts of data across users, networks, and endpoints. In this cybersecurity application, built in Arcadia Enterprise on Cloudera, we start with an executive summary dashboard, which bubbles up threats from the different perspectives that Apache Spot enables: users, endpoints, and network. Notice here the application is prioritizing threats based on perspective. For example, looking at the top user threats, they are prioritized in the context of the entitlements that the user has. Top threats are associated with privileged users, such as our HR user here. Similarly, if we look at the top threats from the endpoints, we're using context from the endpoints to help prioritize those. In this particular case, we're prioritizing based on the regulations governing the specific endpoints. This seemingly simple executive view leverages the open data model and machine learning algorithms in Apache Spot, where we have a defined taxonomy for security for all data that spans network activity. User profiles from sources like the Active Directory, endpoint data from endpoint management systems, or vulnerability scanners, which have data from threat intelligence providers. Bringing these disparate types of data together on a single pane of glass is what enables security analysts to quickly detect and respond to threat incidents and identify cyber attacks across the entire infrastructure. Now, let's drill down into the network activity screen in our application. What we're looking at here are the top threats that have been identified based on network activity data being fed into Spot. You can see the timeline of the activity in a particular time window, as well as the top suspicious flows. This leverages the output of a machine learning algorithm based on LDA, or Latent Dirichlet Allocation, that can analyze NetFlow data. It analyzes DNS queries that we extract from packet capture files, and it analyzes Blue Coat proxy events. In this particular instance, the system has bubbled up a couple dozen threats from potentially billions of records in the underlying Hadoop cluster. The analysis of the data is also done in place within the cluster. When I click on a particular IP address, the application updates the activity associated with it and shows which other endpoints have been communicating with this IP address. Upon seeing this potential threat, as a security analyst, the very next question is, show me all other context or touch points that I have from that IP address around the time this threat was identified. If I go ahead and click on that IP address, I get redirected to the ODM exploration screen, where I have additional context about users, proxy actions, and domains with which this IP address was associated. This allows me to pivot my line of analysis and start focusing on users that were associated with that IP. Picking the first username, J. Smith, I immediately notice a potential suspicion about Russian domains that the user has connected to. This particular domain was registered 6 years ago, but I do not yet see any suspicious activity. But if I look at this second event, I see another Russian domain that was connected to this IP address. This one was actually registered about a week before this connection took place. Adversaries commonly register fake domains, redirect traffic to that domain, then quickly move on. This is a sophisticated attempt to hide tracks, which in this particular case is not as effective because the system is able to cross-reference and identify this activity as being associated with suspicious traffic based on artificial intelligence models in Apache Spot. In summary, machine learning identified suspicious activity, and because of Spot's ability to deliver enterprise-wide visibility, I was able to drill down to get full context and make a decision. Let's now switch to the user screen, which identifies privileged users with suspicious behavior. I can see we have this user in the HR group that is connected to a known malicious URL, repairlabshost.com. This information is available through threat intelligence data that has been added to the underlying data model. The threat intel provider has flagged this as very high severity. Upon clicking on the username, I pull up information about the user profile from an Active Directory-like system. Let's look at another user, J. Smith, that I identified from the network activity and user exploration. J. Smith happens to be a privileged user as part of the domain administrators group, and there is activity from that user associated with malicious URLs. Drilling into all the activity from this user in the same time frame gives the analyst context around what else the user has been doing on the network. What is interesting is this also shows me that another user, WhatsB, has shown activity to the malicious URL, indicating a high likelihood that he is infected by the same malware. Two separate users in different systems affected by the same threat, which brings us to the endpoint screen of the application. As an analyst, I can quickly notice the profile of the endpoints under investigation. The operating systems, browsers, patch levels, and service pack levels are installed on there. It shows the user which regulations the endpoint is governed by and to which organizations it belongs. We can use that information to prioritize these threats. In this particular case, the endpoint itself was seen connecting to a known malicious URL, prac.proboards.com. Drilling further, we can connect other endpoints that connected to the same URL using the Threat Intelligence widget. The value of this unified big data analytics approach is that the user never loses access to the underlying granular data. Just a quick hover over the rows will pull up the relevant attributes across contexts. In summary, Apache Spot combines best practices in machine learning, analytics, and open data models to provide fast and granular insight for security analysts. With varied contexts across large amounts of end-user, endpoint, and network data, cybersecurity analysts can quickly pivot across all the available information at their fingertips and identify and respond to evolving threats. The Cloudera distribution of Apache Spot enables teams to effectively manage and perform machine learning analysis across all available data at a high scale in combination with the single pane of glass or converged visual application built using Arcadia Enterprise. This allows users to see varied contexts or perspectives across all disparate systems in one application or view, unlike traditional security analysis, which requires users to log into multiple systems and perform swivel chair analytics, switching contexts and views to get a complete view of cybersecurity threats.